In this video, we'll answer the question, what is the F distribution? We'll compare the F distributions to distributions that you're already familiar with, and we'll see how you can use Minitab Express to find the proportion under the F distribution. Let's start by reviewing the distributions that you're already familiar with. Earlier in this course, you've learned about the Z distribution. This is a normal distribution. It's perfectly symmetrical with a mean of 0 and a standard deviation of 1. You've also learned about the T distribution. Like the Z distribution, the T distribution is symmetrical with a mean of 0. However, you can see with varying degrees of freedom, the exact shape of the T distribution changes slightly. Here's our F distribution. Like the T distribution, the F distribution changes depending on degrees of freedom. But for the F distribution, we have two different degrees of freedom. Degrees of freedom 1 and degrees of freedom 2. These can also be referred to as the degrees of freedom numerator and degrees of freedom denominator. When we do a one-way ANOVA in this lesson, you can see them called degrees of freedom between groups and degrees of freedom within groups, or degrees of freedom for the factor, degrees of freedom error. This is a table that was made in Minitab Express for 4 different combinations of degrees of freedom. We can see that the shape of the distribution changes depending on the degrees of freedom 1 and the degrees of freedom 2. Now, let's look at an example to see how we could use Minitab Express to find the proportion under the F distribution. Here's our first example. We'll see this again later in this lesson. We're comparing the mean final exam scores of students from 3 different instructors' courses. This is part of the ANOVA source table that you'll get from Minitab Express. We want to use this information to determine the p-value. Recall that for an F distribution, we have 2 degrees of freedom. In this case, degrees of freedom 1 is the degrees of freedom for the instructor, so 2. Degrees of freedom 2 is the degrees of freedom error, which is 242. We need both of those degrees of freedom in order to draw our F distribution for this example. We also need the F value of 1.07. This is our F test statistic. When doing a one-way ANOVA, we'll always be doing a right-tailed test. We want to find the area in an F distribution with 2 and 242 degrees of freedom beyond the F value of 1.07. Let's go to Minitab Express. We just need a blank Minitab Express worksheet. We're going to create a probability distribution. If you go to Statistics, Probability Distributions, we want a distribution plot. We want to display probability. We have an F distribution. Recall that we have 2 and 242 degrees of freedom. Our F value is 1.07, and the default is a right-tailed test. Whenever we're doing a one-way ANOVA, we're always going to want a right-tailed test. So here's our F distribution with 2 and 242 degrees of freedom. The proportion that falls beyond an F score of 1.07 is 0.344626. So this is our p-value for this example. Here's our second example. A research study is conducted in which the means of 4 independent groups are compared using a one-way ANOVA. The total sample size is 120. An F test statistic of 3.57 is computed. What is the p-value? We can use the information in this scenario to determine the degrees of freedom. Recall, degrees of freedom numerator is equal to k minus 1, where k is the number of groups. We have 4 independent groups, so 4 minus 1 equals 3. Degrees of freedom denominator is equal to n minus k. So the total sample size minus the number of groups. In this case, 120 minus 4 gives us 116. We're going to go to Minitab Express, and we're going to construct an F distribution with 3 and 116 degrees of freedom, and find the area that falls to the right of an f-value of 3.57. Again, we're going to create a distribution plot. This time, we have 3 and 116 degrees of freedom, and an f-value of 3.57. Here's our F distribution with 3 and 116 degrees of freedom. The proportion that falls beyond an F value of 3.57 is 0.0162722. This is our p-value.